In last video, I discussed first 15 problems of Grand Test 3. In this video, remaining 15 problem solutions I am discussing. So here, length of elastic string is a meter and the longitudinal tension is 4 newtons, A meters. So we don't know original length of a string. Let the original length be L when that is subjected to a tension. So new length will be much A. So that is nothing but L dash L plus original length and extension F by K. F here is 4 newtons. Here K is constant. Right. When it is subjected to other tension 5 newtons, so another length we given B, L plus it is F1. So another force here, it is nothing but F2 here is 5 newtons. Right. So from here, once you subtract, what you get here, A minus B is LL get cancelled. So K becomes, to find out original length, one by K here is B minus A. By A minus 4B. Now applied tension is 9 newtons. The new length will be L plus. So since we know original length and 1 by K is, so 9B minus 4B, 5B. 5B minus, the second option is correct. Here, it's very important. Total 36 cells are there. So some of them are connected in series, some of them are connected in parallel. Final intention is to that maximum current must pass through the circuit. So we don't know how many rows are there, right? In each row, how many cells has to be connected? Let number of cells in each row be n, like that there are m rows. So each cell is having internal resistance small r, let us denote with. Since all the cells are connected, n cells are connected in series, So effective resistance is like this. We have M rows are there. So NR like this. There are M rows are there. So all these are in parallel. NR, NR like this. So effective resistance will be. So what we get is if two of them are connected R by 2. So here it is NR by M. M rows are there. Now, since N cells are in series, so effective EMF is so like that. Even if cells are connected in parallel, effective EMF will not change. The current, so all these are finally connected to some external resistance, capital R. So this is internal resistance of cell. Current will be maximum if external resistance is equal to internal resistance. Your external resistance is 2. We don't know. Internal resistance is 0.5. From here, N is 4M. So total number of cells in one row, there are N, M rows, Mn cells, 36. So M square is 9. M3, that means 3 rows are there. So N obviously becomes 4M. Here it is. In one row, there are 12 cells. The current will be, so NE by, this is capital R, it becomes 2R. So N here is much 12, 2 by 2 into external resistance is 2. That is 6 amperes. So two rods of lengths are welded together to make a composite rod. If the coefficient of linear expansion of the rod alpha 1, alpha 2 respectively, the effective coefficient of linear expansion of the composite. Length of composite rod is L1 plus L2. So when temperature is raised, new length is L1 dash plus L2 dash. Change in length L1 dash. So delta L is L alpha delta T. So L1 dash is L1 into alpha 1 delta T. So that is L1 dash minus L1 is similarly L2 dash minus L2 is your delta L is sum of these two. Which is L means L1 plus L2 of alpha delta T. Alpha here is So here PQ is one adiabatic path. RS is another adiabatic path. So intersect two isothermals. If this one is isothermal one, it is secondary. So here for adiabatic process, the relation between temperature and volume. So if I choose path PQ, TA at this point P, VA power gamma minus 1 at the Q, TD VD power gamma minus. For RS path, TB VB power gamma minus 1, TC VC power gamma minus. So here once you divide TA by TB, VA power gamma minus 1, TD by TC, but so this PR is isothermal, means temperature constant at P and at R, temperatures will be same. Similarly, QS is another isothermal, temperatures are constant. Right. So TATB get cancelled. From here, I can conclude VD by VC. Here, VA denotes potential at A, VB denotes potential at B. In case VA is greater than VB, so diode is forward biased. So current passes through 30 ohm, both the resistors. So R equivalent will be 1 by R1 R, since they are in parallel. So since they are equal, 15 ohms. If VA is less than VB, diode is reverse biased. So current, very small current passes through it, or no current. No current through 30 ohm resistor, one of the. Then current only passes through this 30 ohm resistor here in this case. Hence, both 1 and 2 are correct. Whenever soap bubble is there, excess pressure is 4T by R, which is HD. So that is balanced by, so column of oil, specific gravity 2 mm high. which is 2 mm. So density is given zero point 0.8. G, you know, it is 10. So radius of 1 centimeter, 10 power minus 2 meters. So here T here is the charge dg by 4. 2 into 10 power minus 3, zero point 0.8 into 10 by into 10 power minus 2 by 4. So it is 0.2, 0.42 into 4 into 10 power minus 5. If you say this is K, 1000 K means 4 into 10 power minus 2 point. If you take 10 as 9.8, you may get 10 power minus 3. Is minus 6, okay, minus 5. So 0.04. From what height block of ice must fall into a well so that 1 by 100 of its mass may be melted. To melt 1 gram, 80 calories, this many joules. To melt 1 kg, this many joules are required. So m kg of ice fall from a height. Because of this energy, 1 by 100th of us mass is melted. Right. So L here is 336 into 10 cube by 100. So 10H is, so height here is 336 meters. The 2-point charges Q and Q2 microcoulombs. So diagram seems to be missing. At A, charge Q1 is placed at Q At C, charge Q is placed. D, which is 6 centimeter distance from A. Q2 is placed. Now the change in potential energy. Potential energy of two particle system K Q1 Q2 by R squared. Initial potential energy K Q Q1 by, because here you have three charges, 8 centimeters. This 10 power minus 2. Between these two also there is an energy Q1 Q2 by, and between capital Q and Q2, which is 8 square plus 6 square, 10 centimeters. So when charge Q move along C to D path and somewhere it falls, now final potential energy will be between Q1 and Q, K Q1 Q by R. This distance also he given. 1 minute, let me check. Radius, right? It is 8. It is obviously 2. K Q1 Q is 8 into 10 power minus 2. Where between Q1 and Q2, K Q1 Q2 by 6 into this, and between Q2 and Q, 2 into 10 power. So change will be final potential energy minus. So these two are anyhow same. They get cancelled out. Here these two also same. They get cancelled out. Only K Q2 Q by 2 into 10 power minus 2. KQ Q2 here is 2 microcoulombs. It's 100 by 2, 50 K Q2 Q. It is 10 power minus 1, 10 K Q2 Q. 40 K Q2. K is 1 by 4 pi epsilon naught, whose value is 9 into 10 power 9. Q2 is 2 microcoulombs. Capital Q is 5 microcoulombs. 1 microcoulomb is 10 power minus 6 coulombs. Here it is 40 into 10, 400 into 9 into 10 power 9, 10 power minus 12, which is 3.6 joules. 54. So to find effective capacitance between A and B, whenever they ask this type of questions, those ends are connected to a battery. So here It's a positive charge because it is connected to positive terminal. Here it is connected to negative terminal. So negative charge gets deposited. So let us name the plates 1, 2, 3, 4. Here plate 1 and 2 form one capacitor. Similarly, plate 3 and 4 form second capacitor. So here 1 and 4 connected to positive terminal. 2 and 3 are connected to here it is 4 and 3 are connected. 4 is connected to positive. So this is one capacitor C1. It's another capacitor. But all our area of each plate is A. Separation is same. So C is A epsilon naught by D. Epsilon naught fixed, D fixed, capacitance will be fixed. So when they are connected in parallel, which is 2C, that is 2A epsilon 1 by D. Answer is 2. Suppose here if at certain instant current 5 amperes and decreasing, I is decreasing, then there is a change in the current EMF is induced by Lenz's law. It opposes change. So whenever decreases, that is replaced by EMF. So it should support. So with the L di by dt, so there will be a increase in the potential. So if it is increases, you have to consider replace inductor by this cell. Here A, since I decreases, I will connect like this. Here is a resistance at a potential. So this is nothing but plus L di by dt. Now minus how much? What is the current which is flowing? 5 amperes. IR 5 into 1, which is equal to. So here inductor is 1 millihenry. Current is 10 cube amperes. VA plus 1. So VA minus VB 4 volts. So here a solid cube floats in a water, may not be totally immersed. So partially immersed or partially floating only to up to height h it is within the water. What volume of the cube is outside the water? So here weight is floating upthrust or force of buoyancy is nothing but weight of liquid is volume of liquid, density of liquid. So here for a square, cross-sectional area is A. So up to this height only liquid is there. A into H. So water in terms of grams, it is 1 gram per centimeter cube. Where mg is mass of the cube when it is in air. So 700 grams into G. So 700 G is area of a square, that is 10 square. Your H area here is, I will write 10 square H. So G get cancelled. H will be, so this is, so that means within the water, so volume occupied is 10 into 10 into 7, 700 centimeter. Outside volume, 300 centimeter. A rod of length has coefficient of linear expansion. Other rod has coefficient of linear expansion. Difference in their lengths at all temperatures is constant. So L2 minus L1 is this, L2 dash minus L1 dash minus L. Here it is L2, which is alpha to delta T. From here, L1 by L2 is 3L1 is 2L2. L1 is already 40. L2 will be 60 centimeters. That is 10 into 10 is equal to 60. A capacitor of capacitance is charged. Charging battery is disconnected. Even battery is disconnected. So energy stored in the capacitor So assume that coil has a negligible resistance and is connected, and then for that, so now charge passes through this. That charge will be stored as energy in the coil in the form of magnetic field. So energy stored in a coil. So both are equal because there is resistance, there is some loss. He said negligible resistance. So he is asking peak value of current, capacitance 25 into 100, 5 into 10 power minus 3. So here it is 1 ampere. It underwater, swimmer is at a depth 12 meters. A bird is at a height 18 meters from the surface. For the swimmer, the bird appeared to be at a distance. So when he observed from denser, so till here there is no change. When medium changes from water to air, or any medium changes, denser to rarer, this bird will appear at more distance. That apparent depth h by mu. Don't consider total distance only. So other medium, what is the distance between surface and bird? That mu here is 4 by 3. Sorry, it's more distance, right? We have a formula mu h. That is 24 meters. In this problem, for maximum intensity, d sine theta here is n lambda. So sine theta is n into lambda 200 by both are nanometers 2n by 7. We know that sine theta lies between, so implies, so integral values in between them. So here you can observe bright fringes above the central fringe and below the central fringe. Here 336 plus 1. So here number of maximum is equal to 7.